Okay, so WebAssign wants us to do it their way. They've drawn a picture. That's nice. The problem is asking for the rate at which the angle between the bus is changing. So here's theta. They want d theta. Okay. So theta, we could, before we read on to the problem, theta is the opposite, tangent of theta is the opposite divided by the adjacent, because this is a right angle right here, right? So from trig, we know that theta is the, tangent of theta is the opposite side divided by the adjacent side. So we know this is going to happen at some point. Tangent theta equals the opposite from theta divided by the adjacent to theta, because this is the hypotenuse. Okay. What are they talking about here? We are given at the moment in question, the rate at which the distance between the person and the bus stop is decreasing. So this is something they say in the problem. The bus travels west. So the bus is going this way. So x prime is 20 meters per second. And I assume the bus is at the intersection. So 20 x prime is 20. I think that might be what they're asking. And they want dy. Okay, so they want this rate of change. Wait a second. Are there two buses? Oh, that's the stop. Bus travels west. I assume that's west. You are south the intersection. So this is us. The bus is 20 meters west. That's fine. You move north at a rate of 2 meters per second. Okay, so this change right here, y is getting shorter because after it's per second, so after 1 second we've made y 2 meters shorter. After another second we made y 2 meters short again. So I'm going to put -2 in here for the decrease of y because we're traveling towards the bus stop at 2 meters per second. So this distance is getting smaller, that's why it needs to be negative. Okay, and then the distance between the person and the bus stop is, at this moment, they said y was, we're 40 meters south of the intersection, so y is 40. The rate at which the distance between the bus and that was the other part I was looking at. This is the bus is going west 20 meters per second, so this distance is getting bigger. It's going to be a positive 20 for x prime. And the distance between them is, it said, the bus is 20 meters west of the intersection, so 20 is right here. All right, WebAssign. This is, dy dt, that is decreasing. We're 40 meters south of the intersection. That should be -2. Because we're going towards the bus stop, right? You move north a rate. I wonder if WebAssign has this wrong and it's supposed to be positive. Yeah, but that's not right. That's confusing. dy dt is definitely -2 because y is the distance from the bus stop to the person. So that distance is getting smaller per second. It's not getting larger. So that should be negative. So I'm going to try to report that to WebAssign. I've only had it happen about twice in all my time teaching with all the different texts in WebAssign where I was right and I spotted a mistake, but I'm pretty sure of that. That should be -2 because that's decreasing. But anyway, we now find a relationship between the variables, blah, 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 blah. So that's what I just drew over there. Tangent theta is opposite divided by the adjacent, so x divided by y. And then they're probably going to want us to do the derivative. Yeah, okay, so they just want you to take the derivative. We need to use implicit differentiation because theta, x, and y all depend on a different variable on time. So when you take a derivative of the left side, the derivative of tangent is secant squared theta. But then we also need to multiply by the derivative of the innermost function. The derivative of theta with respect to time isn't 1. It's something we don't know, so we have to write it as theta prime, which is what they wrote here in longer notation, d theta. Okay, but they already gave us that part. This part needs the quotient rule because it's an x and a y, but we're taking a derivative with respect to time. So the quotient rule says this is the derivative of the top times the bottom kept the same, subtracted by the top times the derivative of the bottom, all over the bottom squared. So that's what they want in these boxes. The first one, wait a second. No, they've broken it up. they broke it up as two separate fractions. So they said it's x prime y over y squared. They just rewrote it algebraically. And then we got minus x y prime over y squared. So this first one, if we factor out that x prime, if we write it off to the side, that's y over y squared, so that's 1 over y when you simplify that. And then over here we got x over y squared times y prime, so x over y squared. I did that kind of fast though. Okay, what did I do wrong? Oh, minus. Look, I got a plus here. I didn't see that. But it's supposed to be negative. Okay. I didn't see their plus. We wrote a minus here, but it's plus and negative is the same thing. Okay, so we know all these values. They want you to go back to the original relationship and find out what tangent theta is supposed to equal. So x is 20 and y is 40. So if we go back up here and plug that in, we get tangent theta is, they said x is 20 and y is 40, so 20 over 40 is 1/2. And then want us secant theta is 1 plus tangent squared theta. And so we know what tangent is. Tangent theta is 1/2. So this is going to be 1 plus tangent squared theta, so 1 plus 1/2 squared. So it's 1 plus 1/4. It's a plus. That's 5/4. I think is what they're looking for there. Yeah, because 1/2. Tangent theta is 1/2. So if you square tangent theta, it should be squaring 1/2. So that's 1/4. So that should be 5/4. But it looks like they don't have it set up for a fraction there. Oh, they accepted it. Okay, so there's our derivative that we found. They're plugging in that initial information. They plugged in the 5/4 that we just found for secant squared. They multiplied 4/5 both sides. That's fine. And then in here, so 4/5 is on the outside. I think we need to simplify all this stuff right here. Okay. So 1 over 40 times 20 is 1/2. And then 20 over 40 squared, that's 20 over 4, that's 20 over 40 squared. So, shoot, what is that? I was trying to do it in my head. 40 times 40. Some days you can feel your mental math isn't good, so trust the calculator. So cancel out those zeros, divide the top and the bottom by 2, so that's 1 over 80. So 1 over 80 times negative 2, that's negative 1 over 40. So that's 1/2 plus 1 over 40. So top and bottom, multiply that by 20. That's 21 over 40, I think is what I got. It was a little fast. And so d theta dt, we just need to finish that fraction multiplication. I got 0.42. Let's see if it'll accept without a fraction. I don't want to change that to a fraction. Yeah, it's cool with it. Okay.